Testing microphone.
Good. So we are getting ready to start, and we'll have our slide. Yep, there it is. So, välkommen. That's it. That's all I know of Swedish. And thank you. You are now in. Okay, thank you. It doesn't, this looks like a mic, but it is not a mic. Not for you. It is for that one is also not a mic. This is the mic right here in my voice. And so we are doing this for those who are online. And so this is hybrid. We have those joining us as well as the virtually, as well as those who are here online. And so thank you all for coming to this session. This is a joint session. So this is, you weren't listening, looks like a mic, and it is only for the people who are online. We all have to speak loudly, and then we will be heard. And so this is Breakout Session 2. It is a joint session. The first session will be with the Materials Data Interest Group. And then it will switch over to the engineering interest group. And so let's see if this gets us into the second slide.
The big button. The
Big button.
black button.
And now I need to go back. All right. And so just to show that you will be out of here in 90 minutes, this will be the breakdown for the two groups. And so we'll start with the Materials Data Interest Group and have a series of presentations by a number of people from different organizations. We are allowing 10 minutes at the end for discussion at this for this interest group. We will then hand it over to the data management engineering interest group for their presentations, and they will also have discussion as well too. Just to give you a little background for the materials data interest group, today actually started in P18, and there was a session that our interest group ran. We had a number of different countries represented talking about what they were doing in their countries as it related to materials data. And one of the points that came out of that discussion was that, is there a way that there could be some commonality or some common theme that groups could take part in while still being working in their own national interests? And so we tried to keep that going in the following year by having monthly presentations, starting with the initial group that only got to speak for 15 minutes. We actually gave them a full hour, and we did that on a monthly basis, and again tried to come up with some interest in moving beyond just simply talking about what we are doing in our country and moving more towards some potential collaborative work in materials globally. What came out of those monthly meetings was, even with COVID, an interest in a small workshop. And I'm at Northwestern University, and so we agreed to host a small group to come for a week's time and try and focus on a particular area. What came out was a focus on laboratory information management systems, LIMS. And so what you're hearing today is an outgrowth of that initial workshop. The intent of that workshop was to try and crystallize an idea, bring it back to the RDA community, and see if we could get broad interest within the materials community and see how best to go forward. So at this point, I am going to turn this over to Gretchen Green at NIST, and she is going to say a few words about, again, the background of how this was of interest.
Okay, I'm going to wing this a little bit because I just got surprised with I'm giving this slide right now. Um, so anyway, thank you all for joining this joint session today. And I'm happy that we could come together with our two interest groups. And it's been a fun project working on the notion of LIMS. So what is LIMS? Laboratory Information Management System. It really is a system that pulls together a lot of different services and components. And it also offers a means of discovery of data that is being produced in the laboratory. And it also can apply to simulation data too, theoretical data sets. So for the most part, we're going to be referring to laboratory data. So a LIMS is responsible for workflow management, how data flows through the system, orchestration of movement of information. It provides a repository. I think most of us are familiar with that. You can also, in the production or operation of a LIMS, generate data products, develop and implement use of tools within that ecosystem. And how do you organize and assemble your different data sets together hierarchically, linearly, to aid search and retrieval? We also would like LIMS to be able to support long time baselines so that they're reliable and over, but also flexibility. So when you're designing LIMS, you have to account for the fact of this rapidly changing technological space and science in general. And we're also really, as part of RDA, very motivated by introducing standards and best practices, all for the end goal of really trying to support our users. So what does it mean if we're doing LIMS to LIMS? Really, that boils down to interoperability. How do LIMS communicate to each other? How do we exchange information across these LIMS platforms? And the main purposes for this are core to RDA. How do we collaborate on research? And how does that accelerate coming to conclusions and finding new discoveries? You also, do not include the advantage of being able to exchange information across LIMS is you may not have the same thing in your LIMS platform. So it allows you to combine information together, expand your knowledge base. And LIMS typically are focused toward their own user community. So again, you're expanding your aggregate community. And back to the I and interoperability with the talks that follow, hopefully you will learn more about what this means. So I will pass it on to, I think, Ben Long, who is our next speaker.
Thank you.
Yeah.
Thank you, Gretchen, and thank you, Laura. I don't know how this works, so I'm just going to push it, big button. So here we have a diagram just following these talks together. So LIMS to LIMS, right? Imagine the left triangle here and the right triangle are separate systems, right? So let's just walk through the scientific workflow for a moment here. Start on the left there. You've got lab number 1, right? And so right there, the black circle, you have some scientific object. Maybe it's being looked at under a microscope. June runs a whole community around an electronic microscope at NIST. And maybe they're doing experiments deep into battery technology. And so they're looking at batteries of different kinds or different aspects of things relating to batteries. And so like any scientific loop around a microscope, you'll start to see observations, images coming off a high-powered microscope. And that's raw data, right? Flowing from that series of scientific experiments in that lab. And then somebody's got to put that somewhere. Does it go on a server? Does it start to get cataloged and organized and maybe made available and orchestrated in a larger community? And so underneath it, you might start to see an organization that's evolving around that scientific, that very empirical process on the left. And then as that's happening, and you say, wow, a lot of people, there's a whole community of folks who have been studying batteries for a long time at every scale. And there's a whole literature base on the right there. There's papers, there's models, there's a whole history of battery studies. And so somebody over there, our colleague Hank, who can't join us today, but we'll simulate him, he and his colleagues are looking at the semantics and the literature and saying, how do we organize all of that knowledge together about batteries? And maybe folks who are seeing stuff come off the microscope over here at June's high-powered community, they say, wow, we're seeing something. Is there anything about this in the literature? And their system now might start to say, hey, let me see if I can correlate what's coming off that microscope with Hank's community and their system over there. So not just community to community or researcher to researcher, you start to see maybe there's an opportunity for one system to talk to another, one LIMS, one lab to talk to another. And so down the middle there, you see these sort of black rectangles, and you could imagine those annotating sort of a data flow and sort of a system diagram, right? You say, if data in a sense is flowing in each one of these, in this case, it's empirical measurements on the right, and in the left, you have a community of literature that's flowing in, and they're being refined into knowledge in each case. And that's going through some interface, right? A user interface maybe. Maybe it's going through a network of connected things and systems. And maybe there's some way that they talk, an exchange protocol. And that's going from side to side, but within it, as they receive requests that say, well, what do you know? What can you do? Well, I know stuff about batteries and images over here, and I know stuff about semantics over here. And so internally, you have a way of responding to requests, and externally, you have a way of satisfying them. And so through this process and through this last year of working and talking together, we started to say, how can we visualize this? How can we start to formalize some common paradigms and ideas that we could start to share? And so that's what's going to follow in various forms. So this is just sort of a context slide, and June's going to dive a little deeper. So thank you. Big one.
Well, big button. All right. Well, thank you, Ben. I am June Lau. I also work at NIST. So big button. Where do I point the big button? Right there. Okay, very good. All right. So so following Ben's thought, I wanted to suggest a proposal here, right? That we look at some minimum basis set for successful LIMS to LIMS communication. Okay, so we've color coded this, right? And the best way to think about it is the blue set is the internal attribute set. What am I about? What is my LIMS about? And then the red stuff is what does my LIMS do? What actions can it perform? So maybe just to make it a little easier to think about, right? If I were to represent myself as a LIMS, I can tell you all within the blue set, I like reading Shakespeare, I enjoy cooking, and I like to hike. So that will be blue. This is about me. And then in red, I might say, I can recite Shakespeare. I can show you how to make a cheeseburger, right? And then another thing might be, I can recommend a hiking trail to you if you came to Washington, D.C. So that's a differentiation, what I'm about me internally and what I can share with you externally. All right. Oh, how do I?
Button below.
Oh, okay. All right, very good. So, all right, so let's dive deeper into this self attribute set, right? What am I about? What is my limbs about, right? So, we identify 4 sub components that we think is essential for you to set up a successful limbs to limbs communication. So, first, the identifier, right? What kind of limbs am I, right? Some basic limbs info, right? Information about myself, like, hi, I like to hike, right? What kind of user interface do you use, network, etc. Second sub category would be the data set holding that you have, right? What kind of data sets do you do you have? So for example, in the LIMS that we built at NIST for the electron microscopy community, we hold primarily data sets of images and spectroscopy data and hyperspectral, so forth and so on. Third on this list is the model, right? Behind it's your schema, right? So you're organizing all of those images in a certain way, right? So there you have a data model that supports that LIMS. And then finally, it's the tasks, right? This is what your LIMS can do. So, you can identify the content, and so forth and so on. So this is the internally held truths that we believe LIMS should contain. And then, so having gone through the blue stuff, let's go into the red stuff, which is what we can offer, right? This is what the services we can offer you if you came and asked us, right? So we further subdivide that into 2 primary kind of tasks, right? So there are the management tasks, which has to do with, your data sets, right? Is it AI ready? What about the model? What about the data model? And then some definitions and so forth. And then following that, there are the analysis tasks, right? Because given the data, presumably you want to do something with it, right? So you want to, segment and parse, for example, you want to recognize certain features perhaps. And then we want to understand and explain that data eventually, and then maybe discover and grow. So following this, what I did was, so my colleagues and I were gonna present 3 different LIMS scenarios, right? So I will speak for the electron microscopy LIMS at NIST, and then I will pass the baton to my Dave here will be after me, and then we'll go on from there. That's how we're gonna structure this, and then. All right, so we'll go into the microscopy LIMS and what this looks like. And then the blue stuff, what it knows, what's internally true of this LIMS. So trying to kind of step through those 4 things that we think is essential here, right? Okay, so very, very sadly, we don't right now have a LIMS identifying tag, right? So if you type in who am I, right, it doesn't really tell you anything at the moment. Although we're fully documented, this is something that we realize is maybe a shortcoming we should work on for the next development. However, there are some things that we do fairly well. So for example, our data set holding, those data sets are created automatically. And the reason why they can be created automatically is because we have a data model that we've published, right? And it kind of just assembled that knowledge and kind of, parse that out according to our data model. And then, and here on the right-hand side, is an example of throwing some tasks at my LIMS, right? So for example, here we're just querying, can you show me where the diffraction patterns, might be held, for these microscopes? And it does a fine job of doing that. Okay. And then so here is the list of stuff that I might offer you, services that I might offer you, right? So in terms of manage tasks, is it AI ready? And I'm gonna say, well, it's ready-ish in that we have a fairly rudimentary data model, right? But because we know that our data model is not the most comprehensive in the world. What we did do is we saved absolutely all of the metadata tag that comes off our microscopes. So what that means is if you need to segment and parse that data, right, for later use, you could find it, provided you know what you're looking for. Kind of going into the analysis, right? So touched on segmentation and parse. Yes, we can do that. We can recognize, right, in a kludgy way right now. Can it understand and explain? And the answer is no, because that's not why we built it to begin with. But we're, of course, would like to have this kind of continued community dialogue, right? And how might our LIMS evolve in order to accommodate that task? And then finally, I think our LIMS supports discovery, but sadly, it doesn't grow at the moment. And then of course it supports discoverability because we support, thank you for CDCS. We can support things like faceted search and elastic search and so forth. Okay, so the next thing that we did was, I'm not here to talk about the glory of my LIMS, but if you're curious, you can certainly go find out more. This is really a self-graded report card. How did we do? How did we benchmark against those metrics that we've put together, the five of us, right? And I think you will see that on balance we have a little more smiley faces than we don't. So we're doing okay. But the critical part of me certainly thinks we have room to grow, and we'd love to get you in on the conversation and how we might grow. All right. Well, so I'm going to hand it off to Dave now. Thank you.
Thanks, June. So I'm David Elbert from Johns Hopkins, and I'm like the Lorax. I'm here to speak for the trees, and that is to say I'm going to take a little bit different approach to things we think about in LIMS. It may be really premature to say that any LIMS is traditional, but throughout the work that we've done as a group, it's been clear to me that a lot of my work brings a different perspective to the group. So we all wear several hats. We've heard from the perspective of running a facility with multiple instruments and the perspective of somebody working on writing a really feature-rich LIMS platform. But these are what I think of as a traditional LIMS, one that's written as a platform and used to manage information from a defined laboratory setting. In fact, in the material science world, many of us work in many different labs, and we have many different students doing different projects. So the data diversity problem is not just a problem of the types of data, but one of distributed data generation that's distributed in space, in time, in type, and control of the laboratory, and many more things. So in fact, that's really why LIMS to LIMS is so important to us, because we need to facilitate workflows that are end-to-end and link data that really comes across this sort of complicated landscape. There are a lot of technical issues, but this, of course, is also basically an interoperability question, as Gretchen mentioned. So I think the takeaway is that materials projects will never use a single LIMS, so we really need this communication. At Hopkins, we've been working on leveraging interoperability in a somewhat different way to harmonize activities across complex projects. So to do that, our approach has been loosely coupling components of projects through a streaming infrastructure. And I've shown sort of a data architecture on the right side here, which comes from a project I lead called Verimat, which links the Paradigm Materials Innovation Platform and the Quantum Foundry paradigms at Hopkins and Cornell Universities. Quantum Foundry is based at UC Santa Barbara, and both work on quantum materials. Things that can elicit more than just binary states. And so we use streaming, and we built a package in another project that I run called OpenMSI Stream, which is built on Kafka streaming. And so it harmonizes this because it lets our data flow in an automatic fashion from instrument to instrument, and so connects things up. This is recently described in a paper in the Journal of Open Source Software, JOSS, on OpenMSI Stream. I should have gotten the DOI on there, but the paper only came out last week, so it's not there. But the takeaway is that interoperability empowers new paradigms by letting us do this kind of work in a LIMS, and I'm going to give you an example of that. And so I think that motivates and transforms the scientific endeavor. So this is data being collected in a laboratory where we're actually doing an impact experiment. The high-speed video on the left, you'll see a bunch of stuff blown out, but at the leading edge when that video runs, you'll see a little flat piece of metal that comes flying out. That's being driven by a laser that vaporizes some epoxy behind it, and then it impacts a sample and makes shock waves in the supersonic regime. But they have to be in the supersonic regime to be useful. So we monitor that with the little red and blue thing just to the right, which has both the high-speed imagery, and then the green is a photon Doppler velocimetry. So we're taking interference of a laser wave that's been split to actually tell how fast that's moving, so we can tell something about what we've done. That data is collected on an oscilloscope. It's raw, simple tabular data. We stream it with OpenMSI Stream into a cloud broker, and then we process it in an automated fashion. From an RDA perspective, that's exciting because we can extract the metadata and curate data in an automatic way. We also then extract the 2 plots that you see there. Usually all this work has been done manually in the past. And I think a really important thing for us is figuring out how this type of work in an automated way sort of transforms and brings more people into the RDA tent, into the idea of being able to do data work because they don't have to do it themselves manually. So there, those plots actually give back in just a few seconds to the student running the experiment the information they need to run the next experiment, rather than waiting, finding, processing the data. But then we take that data, all the JSON representations of our data model, which is different than June's data model, and our representations of how to actually work with the actual computations that we do. And this gives us a way then to connect between this laboratory and other laboratories where we can install streaming infrastructure, move the data, and process it together. So this is really, I think, a very different way to think of a LIMS that is based around really all this information from multiple laboratories. And for us, figuring out how to make this intercommunicate, either from our analysis platform, something like the SciServer dashboard that we use, or from some other place to find that information is really critical and motivating here for us. And with that, I hand it off to Hank, who's not here. So Ben plays the role of Hank today. I'll just move the slide here.
Yeah, so I'm not sure that anyone but Hank can fully simulate Hank because he's quite an amazing fellow. But thank you so much, Dave and June and Gretchen and Laura. So you can see that we're starting to weave together this very interesting and nuanced picture, which it's not just ours, but this will hopefully resonate and overlap with all of your pictures in some way. And so as June initiated and Dave continued, I will simulate the third part of this, which is, so June's electron microscope community, Dave's community of researchers around complex computations and systems. And now Hank over here, he has an interesting community of ontologists and subject matter experts, global, across the world. If any of you were in the talk preceding this, it was completely on ontologies and mapping terms and mapping concepts. And this is what Hank and his world is all about. And so in the scope of what he would call his LIMS and the information that he and his community need to manage and share, you have everything from curation. You might have people with domain knowledge either that overlaps or doesn't. They might need to curate things just to get, here's the literature base in, here's how it's modeled or how it's refined and integrated. Here's the debate space where we disagree on the concept or the term and where we resolve it, but within a common system, a common forum. And so there's a lot of conversation and information sharing in that kind of a community-based system, a LIMS, if you want to call it that, there. And so on the right, we started to annotate the kinds of things that June shared with us about, well, what would a LIMS like this know and what would it do? Of course, it might have a literature base as sort of its data set, right? And its model, while it might have a schema or some other familiar things, maybe it's got ontologies in there and other things for enriching the representation of that knowledge. How would you do inference on that? How would you share that? How would you mature that? And so just kind of like June did, just zooming in on each of these, we could see a very zoomed in version here. And from Hank's perspective, this is sort of a zoomed in look at what the community of practice who would do ontological work will be concerned with. They might be establishing semantic agreements and mapping. This might go into data formats and terminology. Those might percolate into things that are more stable, like APIs and protocols. And those percolate through the life cycle and the stack, both of what people know and the systems that they make. So this has an impact not just for building things like LIMS, but for also enriching every kind of LIMS of operational practice here that we have, doing real research, whether it's from June's specialized microscopy to Dave's high throughput computational research with his cutting edge grad students. And any community could have a slice like this, right? And so here's yet another example. Imagine if each one of these classes of LIMS started to talk to each other, right? And if I could only push a button, the big button. And so what we learned, you could imagine that this whole series of interwoven talks is essentially sharing with you sort of a pattern, a paradigm of if you could instantiate a vision, not just from our heads, but maybe share it inside of yours and others, what would it take for systems that we might give the name of LIMS or something like that? What commonality could we have so that they could start to share information? How could you instantiate that in just about any way in which you might dream up doing research, where you could think of this as almost like a service and knowledge discovery kind of platform, right? Where you could go to a given node and through a common sort of paradigm, say, tell me, what kind of LIMS are you? Are you a computational LIMS? Are you an experimental LIMS? Are you a knowledge-based LIMS? What do you know about? I don't know that. Can you answer a question for me? What can you do? I can't do that. Can you collaborate with me? And so it instigates system-to-system collaboration. And so this is the vision that we've kind of repeated in these different ways. What we have here is, this is a demo, and I think it's a video that's starting to play. We stood up 2 instances of a system that we have for informatics called the what kind of you're things and ask it for things. And now I have a profile here that his LIMS could ask me for stuff automatically. Over here, I'm standing up Hank's LIMS right now too. It's the early stage, but what's he gonna know? You know how to finish the story now, right? So he says, hey, I'm gonna set up my information. It's a common set of information. I'm a literature LIMS over here. So you can start to say, what other LIMS would I do this for? Let me set up my self-identifying stuff. And that tells you what you can expect and find from me and how we can collaborate. And so what this is doing is he's defining his network so they can share too. And there's some common things, protocol for how they may exchange information. I might want to find information. I want to find a LIMS. So you say, okay, this is sort of prototypey, and we can see these things are actually there. These were live systems that we recorded just to show you. Those are actual schema. And you can see down the left, there's schema for every layer of that paradigm we talked about. What would you like each one to know and to be able to do? How would that work for yours? So over here on the right, this is a Jupyter notebook, but this could be instantiated and built into a LIMS. And we're actually logging into each LIMS here. So LIMS 1 is June, and LIMS 2 is Hank. We've just logged in here. And so now these are actual REST API calls, and they're asking it, show me your LIMS info. This is what we could instantiate under the covers if we all work together. Say, how should that actually work? But we got a schema back, and that's the actual information, however primitive. How rich do you want to make that, right? And so this is really the big idea. And so that's the extent of the demo there. But the intention was to kind of plant that seed for you, that we went during the last year from a bunch of different places and a lot of thoughts into sort of instantiating that through our own work, as well as some systems we had laying around. And so based on this, we'd love to keep talking to you, but we actually would love to instigate talking, self-assembling kind of talking, right? So up on the vertical here on the left side, you see this strange term, which you may have heard in other contexts or not, but connect-a-thon, right? So what we did from beginning to end in our talk and in our interactions over the last year was, you could imagine sort of data flowing from a top of a diagram on down. And this is sort of one system talking to another. This could be yours, right? So what we did is we just kind of started to tell the story. We told stories. What's the story of how your research works? And by telling that story, we started to annotate the diagram of, well, what does yours have? Well, what does yours need? And so in technical terms, if you're a system developer, those are use case scenarios. Those use case scenarios can be turned into software and system architecture and diagrams. You can build research and process around that. So the idea is, this can be very informal, or at whatever level of maturity your conversation is. What if these little, I don't know, half an afternoon kind of events happen, a few hours or whatever, people get together and they start to do this. They say, hey, I care about this use case. Hey, I'd like to talk to somebody more about this kind of LIMS, how it might work. And then people share what they learn. So that was the big idea there. This is a final drill in, but it's more or less just to drive home a final point. When talking about this kind of idea, it's very easy to start to let your mind explode and say, wow, you know, we could put the universe in here and never ever get started. But actually, you could imagine that maybe under these two sort of headers, that maybe you only need 5 or 10 things there anyway in general. Maybe you've almost got a protocol right there. If each one of these LIMS only needs to know, how do I ask another LIMS to find something on the network? You don't need much more than that. If you need to ask it how to share its information, we already showed how that's kind of easy to standardize. So you might imagine that these protocols for sharing and for processing, they could be fairly slim. And then you could instantiate and customize inside. And so this could be an interesting way to think, we hope, and maybe a point of discussion or debate. So that was kind of it. I would like to invite my colleagues up to kind of finish up together and answer any questions you might have. But thank you very much for your time.
Oh, that's okay.
So we ran long, which means our discussion will be short in deference to the engineering group. And fearless leader Laura Bartolo had to leave early. So I'm gonna help run this. One thing that came up in the chat in the Zoom from Zachary Trout was that there is an official link to session notes for people who want to check in and leave notes. So that'd be great if you're in the Zoom or in Whova that you could work there. So we had a couple of sort of leading questions, but we have mics to take out in the audience to see people have things to say or thoughts, contribute. Just identify yourself, maybe.
Yeah, Marek Cybycer from Prague, Czech Academy of Sciences. How do my system knows what data are in your system? Because you started already sharing the data, but how do I know what is in your system? How do I find it?
So one possible answer is, if one were to go back here, And so if you say get LIMS info, right? And what were those attributes that June mentioned? Well, you have defined data sets. We saw in the movie, like you could say, these are the data sets I have. I have a collection of images about batteries. I have a data set about literature on batteries. And then, well, what models or schemas do you have? You sort of self-registered. And so it's simply saying, tell me what you've got. And you've already have that. So it's like a query at that point.
And
Right.
we thought a lot about whether just asking the other LIMS for its schema was a good idea or an overwhelming idea, right? At first, it's a great idea, but a really complicated schema is not so easy to just sort of consume and understand. So there's still a lot of work to be done on unifying a vocabulary and thinking about that. But that's clearly step one. Anyone else?
I'm from Go Fair Foundation. Yeah, you are talking about protocols here. There is protocols IO. How is this related? And are you thinking about persistent identifiers for your LIMS? Because and is this a central system that you are planning to do, or is this a decentralized? So how is it possible? You have really to find it, and that goes only with persistent identifiers. Yeah, and I'm really interested to, understand how I can collaborate. Yeah.
I can take a first a crack at your second half of your question, which is, what do we think about the infrastructure that's required, right, to get these LIMS to talk to each other? So I think the way that's helped me think about it is we're trying to build like the Facebook for LIMS, right? So you go on Facebook, there's a certain, I don't actually not a Facebook user, so I'm just extrapolating. I think that, you could search for like a certain person that you think exists, right? And then they ask you like if this is the right person, like that lives in this part of the world or not. And then you think maybe, right? And then they show you a little bit more of their profile and you're like, yes, that's the person I want to connect with. So I think each, in this case, I think each LIMS probably will need to have a persistent identifier, I imagine. At some point, there probably will need to be a database of these persistent identifiers, and then kind of like what kind of business do they conduct? So that's about the extent of where I think my knowledge ends, and
Which-
then maybe Ben will.
Which could be a working group all on its own, right?
Absolutely.
Just to do that. And I think there needs to be a high level of flexibility there because there are really different views of what constitutes a limb. And I think there's urgency because we're seeing commercial LIMS now come online. Thermo Fisher sells the LIMS. And in my experience in the sciences, once somebody sells a product, interoperability will not be their highest priority.
Bob Hanish from NIST. Full disclosure, June works for me and Ben works with me. Gretchen works for me, so I have a vested interest in some of this. But there are some subtleties that I think are worth mentioning. One is, for example, suppose I just want to compare LIMS from two electron microscopes. One has a pixel scale in nanometers and one has a pixel scale in angstroms. So we have to carry around units. This is my hobby horse and co-data. And maybe one has it has to be converted, its intensity units by a scalar. Another has to be converted in intensity units by a vector because it's energy dependent. So you need more than just a common concept. You need to carry units, you need to carry sometimes more complicated information in order to achieve the interoperability that you're really looking for. That's just the point I wanted to make.
I don't disagree.
But I don't disagree. I just don't think we can start there because what we found was that at very basic concepts of how we communicate and identify, we have to get to those levels first. Is all. So. These last two questions, which is then the engineering group is ready.
And this is Cass from Japan. So I'm responsible for the Japanese Common Data Platform. And I'd like to confirm my idea is familiar with your idea. So I'm asking to my colleague to prepare the super extended DMP the tools which also comes to the automated research workflow. So this is a one-by-one communication, but I need much more in a higher top layer, the data governance, the architecture, which also controls the LIMS to LIMS controller, and from the viewpoint of the starting from the DMP and end to the automated research workflow. So is this? Yeah, I want to get your expression about this kind of idea.
I'll try. I think this is fairly early in this work, right? Where we simply don't know what we don't know. And I think, kind of like Dave was already saying some of this, right? Like we need to start somewhere, right? So we gathered a few people with, several proto-LIMS, and then we just kind of imagined, how do I discover more about that person, right? Imagine if I like ran into somebody on the street and I like total stranger, right? I mean, the first thing that I would identify visually is like, this is a human species and not, some other species like a bird. I cannot talk to a bird and I won't try, right? Okay, so after we establish that, then the next thing is like, well, do you speak my language, right? And so we're really going with very basic things right now. And I think some of the things that you mentioned, right, like the governance, that kind of more like the things that are traditionally like much more rigorous, right? Even like units, right? I think those will come, and we'll figure out how to solve those problems when we make it to the next step.
I just wanted to say, I think we're going to have a little bit more time. I'll explain in a few minutes. So let's just continue with this great discussion.
Yeah, I think it's my question. Okay, I'm Heike Görzig from Helmholtz Center in Berlin, and I'm thinking about the term LIMS also, because I really think you've done here a really great work about like also describing the information, what can be done and all these things. But we have a data repository, yeah? And we would never think about using this if it says LIMS there. So, but it might apply what you are doing here to a data repository. And we have like in the photoneutron community, we have created like now a search API for photoneutron sites. Like we agreed on a common search API, and think that could apply really here also. And then the other thing is. Also, there's also said already what is a LIMS and what applies to it. For example, there are ELABs, for example, and sometimes you don't know if it's a LIMS or it's a ELAB. Or there is this exchange standard now. So we're talking about row crate, for example. Also for exchanging information between these ELNs. So just
You want to answer?
Yeah.
You want to answer?
Oh, no, I just was I'm jumping in just as part of this team. And just to say, I think you made some really excellent points. And we are, as June said, we're kind of early in this implementation. We've taken a very practical approach here with some concrete systems and tried to tackle it that way. But with the full understanding that there's a lot going on in our community. And I think in time and through organizations like this and RDA, we're going to start seeing some commonalities in some of these methods. Standard protocols are coming. When some of the tasks, when we started talking about exchange protocols, we started kind of at a very blank slate, open-ended. We have REST, we have APIs. But ideally, what we learned in the astronomy community, what we want to do is we want to move toward kind of standard protocols exchange, especially for those higher level discovery tools, because there's too much guesswork if you don't know all the different flavors of APIs out there. So yeah, hopefully we will move in that direction in a community, you have a little bit of both. You know, you keep the flexibility of the custom type of thing going as well, but standards will also allow you to build much more robust stacked solutions. So hopefully we'll get there too.
Hi, I'm Sammy from the University of Southampton. So a few things. I was thinking along on similar lines, having looked at a lot of electronic lab notebooks and the different offerings from more from a UK perspective, but the different offerings for lab management systems out there. And a lot of things are kind of coming under slightly different names, and there's also lab execution systems and scientific data management systems, a lot of which may or may not link in with this. And sometimes you have ELNs that are parts of LIMS or not. So I guess it's, one kind of how would you handle that? Two, I wasn't entirely clear, are you, because you showed sort of filling in about the API, are you assuming you would work with the vendors for information about their APIs or their LIMS or their systems, or would you kind of hope to maybe extrapolate some of that automatically from their APIs? And also what about, because obviously you've got some LIMS or ELNs that are very, very generic, they're trying to cater for lots of different scientific disciplines, but then you have some that are very specific. So if you had really quite different disciplines, would you expect them to maybe be able to work together or not? Are you only kind of thinking on a, like you talked about materials, people using more than one LIMS, would it just be more a specific sub-discipline?
I'll take a stab at that because I think your question is going to nicely segue into our next interest group discussion. So I don't have a simple answer to all your great questions. I will say that the one LIMS system that we're working with is not a singular tool. And we are starting to introduce eLab FTW, for example, in one of them, which has its own APIs and own ways of interfacing to it. So, there's a way that we can look at how do we want to maybe even register APIs that are coming from different sources throughout the system. It's not once you get to the end of the system, you could actually probe at different stages of the workflow too. So I don't know if that really is a complete answer to your great question, but we would be happy to have more discussions with you about where you're coming from. And at any rate, we probably should begin to segue to the next interest group. And I think we're going to have time at the end. So are we ready to shift gears? I also wanted to encourage people. I don't see anybody online entering questions in the chat, but we do have the chat window open. So if people would like to submit questions, please, that are attending virtually, please feel free to submit your questions there, and we'll keep an eye on that. Oh, it is? It made it? Oh, great. Okay, good. We did get we were having technical difficulties, but I think we filled in.
When you advance your slides, there's a lag from what you see on this screen, so just trust it. Press the button, it will advance.
Okay, perfect. Okay, are we ready for the next slide? Okay. Okay, I think we went through this. Yep, next slide. Okay, so it's going to Yavis.
Welcome to
Okay, that's not the first slide.
No. First, we have 2 slides.
Two slides first. Okay.
Yeah.
Then we'll take the slides first.
No, we're doing something different. Okay, just to give you guys a little bit of understanding why we're struggling up here. One of our speakers is unable to attend and has submitted a video. So we're really trying last minute to slip a video presentation into the sequence here. So thank you very much for our gracious technical support people. Yeah, no, this is perfect. So part two of the joint session, I'm here with my co-chair Daniela. Our other co-chair Kevin Logan couldn't make it today, but we have somebody presenting in his place. So we're the research data management and engineering. As you might know, it's an interest group focused on engineering. And next slide, I guess that's me, right? I do that. Okay, so the overall session had two parts. We're over in the green session, and what we're going to do is give a quick overview of this past year. What we did in between the last two plenaries is we had a e-seminar series. We had 10 presentations. Actually, we had one from Nexus LIMS, which is where we formed the idea of combining efforts. And our e-seminar series was on ELN at LIMS, and you'll hear a little bit more about that from Daniela. Next, this is what we've slipped in, is Tobias has provided a video for us to watch, and stay tuned more for that. And then we'll follow with Isadora. She's going to give a presentation virtually. She's attending remotely to talk about this new, really super cool journal. If you haven't heard about it, ING, it's for German engineering, .grid. It's an e-journal for data software, and you'll learn about that. And then we'll try to save some time for some questions. If we don't, we'll move on. And then we really do, we've promised with Tova, we're having a 5-minute, we call it a BOF, but we folded in this special topic on ELN just to save for the last 5 minutes. So I'm going to turn this over to Daniela to summarize. And
Okay.
again, if there's any questions with the virtual participants, just send it in the chat.
Yeah, okay, so what we have done, so our interest group was formed at P12. Is it so late? I thought it was earlier. Okay, yeah, it was formed at P12. We had a first session at Botswana above, and then, yeah, we made the whole process in RDA. We were running an interest group session at each plenary. I think we only skipped the last one because there was not so the spirit of RDA anymore in these virtual plenaries, or in our session, maybe it was. And therefore we decided to go for an e-seminar series. And we are coming to this later, and we also had other efforts. So we are also part in the working group on the discipline-specific guidance for DMPs. We also had some joint sessions with the small unmanned aircraft. Yeah. Data interest group, and as well with the metadata interest group, we also had there an e-seminar series with the metadata, but it's yeah, still far away. But all these e-seminar series, so the slides can you found on our repository. So next slide. Yeah, so really shortly, just to give you some ideas about what we have done in our e-seminar series. We first started with the questions how to find an ELN, and next, yeah. And there is this ELN guide and finder that supports the researchers to find the right ELN. As we had it in the series, they were not, so it was a prototype, but now it's quite a really, yeah, productive tool. So it's community driven, everyone can help, so check out the website for that. Then we were discussing about ELN in teaching, how can we move on with that, so we had different universities included it in practical lab courses, and we said that it should be a hands-on teaching, and it should be as early as possible, also without maybe changing the curricula. Then we explored different ELNs and academic labs. So we had open source ones like the eLab FTW, the Kadi format we heard about, the RSpace, and the FurtherMind. And in one of our last sessions, we had the LIMS in labs. So June was also their speaker. So when you also need some more information, it was only short here, 10 minutes. Check out the slides. You have to click, yeah, for the talk. So there will be much more information provided. So all the slides about the eSeminar series can be found in our repository. And now we want to move on a bit more. It was, he's not around with us anymore, who had the question. So we want now to have a look at Jarvis. This is provided by Tobias Hamann. He's working at the tool laboratory at RWTH Aachen. And Jarvis is a platform who wants to connect the different tools, the different informations, and it could also be maybe that ELNs or information from ELNs could be provided there. So we would start.
Presentation of the Joint Assistant for Research in Versatile Engineering Sciences, or in short, Jarvis. I'd like to start off with a little story time. And on the one hand, we've got a researcher called Gerd Papernote. He has an initial situation of several years of experience in research, and he would like to manage his research data now. Because after colleagues have left, it was very hard or even impossible to reconstruct data and results. Therefore, he'd like to manage this data he's collecting, but he has never done so before. On the other hand, we've got Franziska Research. She has a very similar situation with several years of experience and the same wish to manage her research data now. And she has never done so before either. However, she has heard of Jarvis. And now both ask themselves the same question: where to start? Where and how should I start with research data management? So in the first condensed step here, we would like to take a look at the collecting data. And Gerd, on the one hand, asks himself, how do I document my data management and my data collection? Well, he doesn't know what a data management plan is. So he reads a summary about this topic, and after some searching, he finds out how to do it and what's expected of him. And he writes one down in Word. He also has to determine some parameters for his research, and these parameters are not known to him, so he has to collect this data from scratch, and he has to really come up with his own idea and how he could do this project. And he does not reuse any data at all, and he stores his data on his personal computer. He also saves his collected data on the Institute Drive in a project folder, so that it doesn't get lost if he loses his PC or something happens to his PC. On the other hand, we've got Franziska, and she doesn't know what a data management plan is either. However, Jarvis shows her tutorials telling her what a data management plan is, how it can be used, and after she has filled out some basic information in Jarvis itself, it sends this data to RDMO tool for data management planning, because on the one hand, RDMO is recommended for her, and she could choose if she wanted to use RDMO or, for example, DMP Online. And she decided, based on recommendations by Jarvis, that she uses RDMO, and the data is automatically sent there. Of course, she has to fill out some additional forms and questions, but in general, the data she already inserted does not have to be inserted again by her. The second step is that several repositories are recommended to her by Jarvis, showing her data she can reuse, and by this data she discovers there, she is able to specify her parameters very fast and can optimize those parameters quite quickly. Also, Jarvis suggests her to store the data in a fitting repository and lets her decide whether and how she can proceed with her data. And by doing so, Jarvis suggests Cosine to store her data and archive this there as well. We will see how this turns out later. Now, both would like to analyze their data. And of course, the analyze phase has to be documented as well. So how do I do so? On the one hand, we've got Gert, and he is writing his own code to evaluate his collected data, and he does so in Python. He's writing this code pretty quickly because, after all, he knows what he's doing, and he knows how it works, and types down the code pretty quickly. And he doesn't provide description of, for example, required inputs, because, after all, Gerd knows what he's going to input in his code anyway. So he's not using any comments and no versioning, because that's written so quickly, it doesn't matter. Gerd's code remains on his computer because no one else really needs this code anyway, right? On the other hand, we've got Franziska, and she does the same approach as Gerd does. She is writing her code in Python. However, Jarvis points out that the code should be well documented, and it should be reusable for others if they ever do a series of experiments like she did before. And she should document the code and the required inputs to use her code. And Jarvis points out training to Jupyter notebooks, of which Franziska never heard before, but it's a great way to document your code and also your inputs and give additional information on your code. Another tutorial that is presented to Franziska is a tutorial about Git, because versioning her code is a good idea and a best practice. And she should do so, and Jarvis points this out to her. Okay, both now have analyzed the data, and a few more steps are going to be needed to finish this research project off. 8 months later, both leave their institute and are finished, and everything is done, and now a new phase appears, and this is Charles' new guy. And Charles would like to reuse data from his colleagues, like the same problem that Gerd and Franziska had before. And on the left-hand side, we've got still Gerd's project, and Charles could find some publications there, or one publication at related published data, and there was data on the Institute Drive, but it was not very well documented, and the results cannot be reconstructed, and the evaluation scripts are missing, and this is one major issue Charles has with the data of Gerd. he could hardly reuse anything because very important information was missing. On the other hand, we've got Franziska's project, and there's also a publication with related published data. However, this published data is much more documented, and Charles can also find the raw data, the scripts used for evaluation, and the results. And as this project was pushed to a GitLab, everyone from the institute can join and can assess. There was much more data he could reuse, and also it was very well documented. Franziska's data has a higher value. So yeah, Charles could really reuse and benefit from Franziska's data. So I know what Charles is going to ask right now. What exactly is this Jarvis thing and what does it look like? Well, the general idea is that Jarvis gives a structured process for research data management and guides researchers through their everyday research data management tasks. This is very important because research data management is often seen as additional effort. However, if it is implemented in the daily work, it can be very less of additional effort and just something you do along the way. And this is what Jarvis is aiming for. It also provides knowledge if needed. For example, if you're doing a task for the first time, you get infos on how to use a specific tool or how to perform a task in general. For example, data management planning. If you've never done so before, you're probably asking yourself, what should I do and how? Data provided by NFDI for ING as well there, and gives context to these tutorials. It supports with RDM making decisions. For example, if you're asking yourself which directory or which repository I should upload my data to, Jarvis got you covered. And we've got a mock-up here of the interface. It's currently being developed. That's a rather old state. It's, as I said, a mock-up. We've already got some implementation going on there. It's not ready to use yet, but hopefully soon. I've got a roadmap ahead in just a few seconds. But first of all, I'd like to show you how the general structure is, to think about that for a second. I've got the front end with a slightly newer version of the mockup here on the left-hand side, built up in Angular. And in the back end, we've got Python Django running with a very strong REST API to provide access for several services to be connected to Jarvis, for example, RDMO or Cosine or other services. So we'd like to provide a communication between existing solutions and Jarvis and reduce the effort to put data from one service into another and reuse actual information there. So we've got also several databases connected to the backend there where different kinds of data are stored. That's something you can look at and we are working on right now. However, next up, we've got the data model. That's also still work in progress. What I'd like to point out here is that we would like to implement, on the one hand, a very strong connection to metadata for ING from the NFDI for ING consortia. And on the other hand, we would like to point out that there is self-documenting code going on in the Jarvis project at the moment. This UML diagram was automatically created by a CI pipeline running on our GitLab, and it takes basically the models implemented in the backend and transforms them into a UML diagram. So here is the promised roadmap. Currently we are in March, and we hope to implement Jarvis further, that we've got a working minimal viable product, or short MVP, in the end of September 2023. And afterwards we will continue the implementation of Jarvis services and enhance its functionality. So what are the two takeaway messages for you today on this presentation? On the one hand, we've got that the very important point that research data management is obviously very important. And we come to the conclusion that researchers lack a guidance in the RDM process, and the tools that would help in this process are often not known. And so this guidance would also include tools and services that could be used in research data management to support the work of researchers. On the other hand, we've got additional effort that should not be a reason against RDM, but it should rather be reduced so that it is not seen as a reason against research data management. The second takeaway message today is that Jarvis is going to support research data management with guidelines and guidance, and imparting knowledge in the right places and partial automation. With this, I'd like to conclude my presentation here and thank you a lot for your attention. You can also find this presentation slides on this QR code, or if you want to use the DOI for that, here's set one. Thanks a lot and have a nice day.
Okay.
Okay.
We are handing over now to Isadora, who will give us
Skip through these.
who will give us some points for Ingrid.
Okay, go ahead, Isadora.
Okay, good afternoon, everyone. Can you hear me? Okay, so I'm here on the behalf of my colleague, Kevin Logan. And now I will bring some insights about Ingrid. So Ingrid is a journal that came to fill in a gap. And it's focused on fair data management in engineering sciences. So in the journal, we welcome contributions from all engineering subject areas, and we also encourage interdisciplinary exchange of experiences within and also beyond engineering sciences. Ingrid, it's on its way to be fair. And for this, we follow some steps. We're building some steps to be a fair journal. And through all this structure, we're taking all the principles, the FAIR principles into account. We work with an open source publishing platform, with an open peer review process and a preprint server. And this is run by the Janeway. And we also taking into account some transparent submissions, open access, and linked metadata. We are right now an open access Diamond journal. So the process for open peer review in the journal, it's a process that first can bring some increased transparency, improved review quality, and open scientific discussion and an engaged community. With this process, we have a preprint that is first checked by the managing and the topical editors. And then we publish this preprint on the preprint server. So all the roles in the journal are very important for this process. We have the authors, then we have the managing and the topical editors, who are like doing the first check of the submissions to the journal. So we published the submission in the preprint server, and there reviewers are invited to comment on the submissions, but also the community that is registered in the journal can come and comment on the submissions as well. So back. Yeah, the submissions from the preprint server. The preprint server is directly linked to Ingrid website. It's a bit next, yes. And so in the journal, we count with 3 types of submissions. And these are manuscripts and tutorials, data sets and APIs, and software. So in all these cases, the submissions, they should include minimal examples of utilized research software and sample data or course material. So we have this triangle representing that all the submissions at Ingrid depends on supplementary material from the other 2. So these are the types of the submissions represented. And for those who are interested in checking our preprint platform, you can scan the QR code right now. And this leads directly to our preprint platform. So in the preprint publication, we have the persistent identifiers that are also directly connected with and linked with the submission that will go after the open peer review process that will be published at Ingrid website. And yes, this is an example of how the preprint server works. We have here an example of a publication that is right now on the preprint server. So, and it's being reviewed by the reviewers, and also it's open for the community. So who wants to comment in the submission can just register the preprint platform and then bring comments and other points that are relevant for the discussion that it's being brought in the submission. So, and in the end, all the details of this submission, the preprint server are available together with the submission Ingrid website, always with the use of persistent identifiers to connect one another. And with the QR code in the orange box, you can access Ingrid website as well. Yeah, can. This is just for information that right now, together with the library from the TU Darmstadt, we're building a journal knowledge graph. So the idea is using the metadata of the publications. We are trying to make all the publications interconnected, so they can also show this how these topics are interconnected and supplementary alongside the journal. And here's just to show a bit of the timeline of Ingrid. So the journal started with the constitution of the editorial board in November 2021. And since December 2022, we launched the first call for papers in the journal. And we're planning the first issue for this year, 2023. So as I said, the call for papers is open. So everyone who's interested can enter the website, read our focus and scope, the author guidelines, and to read about our open peer review process. All our publications are also set up in a LaTeX template that it's also available at the website at the moment of submission. You can follow Ingrid in social media, and we also would like to call interested people to be part of the reviewers of the journal, or also to be part of the community of the journal, just to enter the preprint platform to help to build to build the community in general, like to comment on the preprint submissions that are already there. We already have some preprint submissions published, so I would like to invite everyone who's interested to take part of it. Yeah. So yeah, thank you all very much for the attention. It was a bit quick, but I hope it could be understandable. And if you have some questions, you can just write me on the chat or ask later in the questions session.
Yeah. Thank. Just to respect people's time, I think we're going to go to our last speaker. We have a one-slide presentation on a BOF topic that Tovo here was going to share with you.
Thank you. I'm gonna make it very quick because we are late. And a part of what I'm going to say is has been already told. So I'm Touv, Robert Manonsou from France, and I'm here to share a work production we've made, and also to offer our cooperation with the team who developed the ELN Finder. As you can see, you can find ELNs, and the problem is how to choose one. So our work was to make a recommendation on the how to choose and which point you need to focus on, which is important or not on choosing your ELN, and depending on your priorities and on your use of the ELNs. So we've made a document in French, which is now translated, and our proposition is to complete the ELN Finder with we've made an Excel sheet to weight the point you can find important or not on your choice. So that's it. I think we don't have any link here, but you can find the English version on our proposal. So that's it. So if you think it's relevant to work together on this and go through, not just finding ELNs, but help people to choose one, we're here. Thank you.
Yeah. Thank you very much, Tovo. And I think in the future, you know, this maybe an ongoing activity with the ELNs that we could potentially have for a future topic discussion. So keep this interest group in mind. We're running to the very end, but we did want to allow if anybody has a question, we would like to take questions. Go ahead. And I think, is this a, yes.
Thank you. All right. So I have one question. It's for Isadora on Ingrid. So the question is, so some people like to already submit their preprint on archive or bioarchive or whatever, right? Actually, two separate questions, but they're related. So going back to the first one, how is your system compatible with people who submit on archive, and then you can just like slurp that in because there's already a DOI and so forth? And then related to that is, I really like the comment section, right? You could kind of track all of the comments as your preprints come in. Do you make a distinction between societary comments, which like on some of the archive stuff, right? People might tweet, you know, they say like, wow, this article is so cool, versus the more peer review type content?
Hi. So I think a difference that we have, for example, I think you mentioned this platform such as ResearchGate, for example, that you can publish your preprint and have a persistent identifier. And so one way of the journal, I think it's to make this process more transparent. So we show all the steps of the submission to everyone. And we also want to bring everyone to collaborate on the steps of the submission. And in the comment section of the preprint server, we differentiate these comments. So the reviewers are invited by the editors to make the traditional reviewers' comments. So they bring proper insights about what should be improved or not in the manuscript. And by the other hand, the community can do this type of comments as well, but they can also bring just these social comments like, yeah, very nice job or so. The authors, they're not obligated to answer to the community. So whatever the community comments, it's not an obligation of the authors to address the comments of the community, but we think that generates not only, for example, someone can see something in your work that you haven't seen before, or someone can have a very good insight for this or next works, or to create networking. I think the community role in the preprint platform works like this. So being everything open and linked to the journal, I think it's, yeah, we increase the transparency of the process of how the review happened and why the final submission looks like this when we publish in the official edition. I don't know if I addressed everything, but yeah.
Very much. I think we'll wrap it up. If there's any questions, I want to say thank you to all the speakers for the joint session today, and just give everybody a thank you. And I'm sorry we were running late. Thank you for your patience. If you have any questions, feel free to reach out to other people and that you know. Thank you.
Thank you. Bye-bye.
Thank you, Isadora.
Bye-bye.